Hello. Today we are going to implement one of the missing pieces of our assembler project. We have a nice instruction library, not complete, right, but we have it. We have an instruction card, which again is incomplete, but it runs, it works. And we have our assembler widget, which is totally unfinished. It's just like the prototype that shows that it's possible to kind of extract values from a separate thread of machine code actively running. So here is kind of the state of the art of our assembler. It has a lot of situations where it will crash. It has terrible UI. I will show you how we want to make it look like. This one. So this is how it is actually going to look like. It's going to have a hand that's going to point to the currently executing instruction, and all of the registers which have non-zero value are going to be displayed here. And a lot of things should be very interactives, like clicking those positions, like touching them maybe with a finger, should trigger the bits in those registers. Actually, it's not exactly how it's going to look like. So I wanted to put some hexadecimal values here, but I'm afraid hexadecimal values are going to be a little bit confusing. I'm not super sure about them, so we'll see. We will also do one more thing. So I was kind of catching up on the Future of Coding Slack, and I came to the realization that there are so many interesting projects being posted on that it would probably make sense to go through them on stream. So we'll go through three three threads that I kind of just found on this Share Your Work forum, and we'll just scan through them. This one, let's start with this one. So I will pause the music, bring the volume a little bit up, and we will take a look at this. So this is made by Paul Tarvidas. He has a blog on Substack where he publishes. He talks a lot about programming close to the hardware and about how he has a lot of topics about, let's say, how things came to be that we currently take for granted. He used to work, I think, in hardware. So let's see what he has to say.
Came from time sharing that was needed way back, origins of multitasking and coroutines. Both these concepts and what we call concurrency came from time sharing that was needed way back when computers were first invented. Back in the day, a CPU was just a simple chip with some sequencing circuitry and a private, super-fast memory called registers. The CPU chip was supposed to be connected to another set of chips that make up the main memory for the CPU. The main memory was divided into 4 parts. The code, which are instructions that control the sequencing circuitry, were written in binary and called opcodes. Initialized memory, which are strings and constants that are ready when the program starts running. Uninitialized memory, which is blank memory that can be used by the application code to store data. The stack, which is blank memory that is used by the CPU and the application to store temporary data, like subroutine parameters and partial results. When you put data on the stack, the memory cells can be reused by each subroutine, thanks to built-in hardware operations and the stack pointer register, called the SP. And guess what? The hardware takes care of efficiently garbage collecting the data on the stack. Early CPUs didn't have a dedicated stack pointer register, so programmers had to provide one explicitly if they wanted to use recursive subroutines. Memory is a big array of cells, and pointers are array indices that let us jump to any cell in the array. We can access any cell in the array.
We see a 16-bit machine.
Called a pointer. Stacks are also like arrays of cells, but the index goes up or down in a specific way. Stacks don't let us jump to any cell randomly, but they can be cleaned up very efficiently by the computer. When we create new objects at runtime, we need to allocate memory for them. This memory is usually stored in a heap or on a stack. Recursion is like a loop that keeps calling itself. When we use recursion, we make copies of variables, like parameters, and store them in new memory locations. These copies are like little stacks that prevent previous values from being overwritten. The computer takes care of cleaning up these copies when we're done using them. But here's the thing. We learned that closures, which are like functions that can remember things, need to be stored in a heap instead of a stack. This way, they can live longer and be passed around as regular functions. Lisp 1.5 is a stack-based engine. McCarthy used a heap-based garbage collector called Mark and Sweep, but Justine Tunney recently showed that this is a bit of a hassle. Since all memory cells are allocated in a strict stack-like way, we can simplify garbage collection. Due to budget constraints, we had to run multiple applications on a single CPU. We loaded as many apps as memory could hold into memory at once.
That was a very interesting thought. I would like to hear more about this, but let's continue. So Justine Tunney, I'm familiar. So there is a blog online, I think, which talks a lot about recently about terminals made by Justine Tunney.
We divided the code memory to fit the apps, along with some shared operating system code and libraries. The operating system created in-memory data structures for each app. These data structures had enough info to save temporary results, like register contents, along with the corresponding stack pointers and program counters.
This is, by the way, exactly what we are using when we do ptrace into our assembly thread. We are actually accessing the Linux context. This user struct that Linux uses, it's actually used to store registers of user space programs which are paused.
Process on hold. The operating system copied all the important registers and data into the process descriptor data structure for the currently running process. To switch to another process, the operating system copied all the saved register data from the process descriptor data structure into the actual registers of the CPU. Then, the actual CPU PC register was set to the saved PC, and a goto was effectively performed to resume running the chosen process. We took extra care to make sure that registers were copied in the right order and that no registers were overwritten by code from the operating system itself. We needed extra code to handle the edge case for startup. The next process runs using its own slices of memory, code, initialized, uninitialized, stack, until it decides to yield back to the operating system. This process, yield, swap out, swap in, resume running, is called context switching. The operating system sets a hardware timer to limit the amount of time each process can run. When the timer runs out, the operating system wakes up and performs a context switch, forcing the currently running process to give up to another process, usually in a round-robin manner, to give each process equal time. Adding features like tracking privileges for processes makes the operating system more complex. In the case of priorities, the dispatcher decides which process to run next. This increases the chances of bugs in the operating system. In a well-designed system, priorities are rarely needed. A famous operating system bug happened when the Mars Pathfinder landed on Mars, about 120 million miles away, and its software crashed. The bug was traced to a problem in the Wind River Systems VxWorks operating system caused by the use of priorities. To avoid that kind of bug, a technique called priority inheritance was invented. The bug probably wouldn't have happened if the Pathfinder had used multiple CPUs instead of time-sharing a single CPU. By the way, coroutines don't actually coroutine with each other. They coroutine with the operating system dispatcher function. Imagine a bunch of apps running on your computer, each vying for the same memory space. If one app goes overboard and uses too much memory, it could crash the others. To prevent this, developers added special code called bounds checking to the compiled code of each app. This code would catch any memory violations and cause an error. But it wasn't enough. The original idea had a flaw. Each app had to be compiled to a specific location in memory. If an app wanted to access a particular cell, it needed to know the exact address of that cell. This was a hassle, and it made it difficult for developers to make changes to the apps. So, developers came up with a different solution by punting work to the hardware. They added more circuitry to the CPU called memory management units, MMUs. The MMUs could slice memory into smaller chunks called pages. These pages could be scattered throughout real memory, but they would appear contiguous to an application. The MMUs would map each CPU address to a different address in real memory.
What I'm looking forward in this video is some, in addition to history, Paul also has some nice philosophical perspective on how software should be written. This is what I really like about his blog. Maybe we'll get a little bit of that at the end.
This new system made it easier for developers to compile apps to the same address. An app could access memory or use jump opcodes regardless of the final real address in memory, as long as the hardware remapped every address to the chosen location in real memory. This reduced the amount of work needed to be performed by the compilers, while increasing the amount of work performed by the hardware circuits. But there was one more catch. This new system added more code to the operating system. Every time an app switched contexts, the MMU had to reload the page registers using values stored in process descriptors. This was a bit of a hassle, but it was necessary to keep the system running smoothly. With the paging scheme, based on hardware MMUs and page registers, it became possible to leave some pages on disk. This was a much cheaper storage option. Hardware circuits would map CPU addresses to real addresses by accessing the MMU page registers. If the circuit detected that a page wasn't in real memory, e.g. by checking a bit in the page register.
Virtual memory is cool. I see the benefits of virtual memory, but because it creates this indirection, it causes memory to be different for every process. It looks differently from the kernel and differently from literally every app on your system. The only two processes which can see the same memory are two threads of the same application. It just complicates the programming model so much. I think without MMU, working with machine code would be far easier. Because it would be just a lot easier to understand how computers work. I mean, I can explain to somebody that, hey, we have this unified view of memory, but then this view is actually different for every program, but it's actually the same memory under the hood. So it complicates the programming so much.
The hardware would wake up the operating system to load the page from disk into memory. The loading process might need to free up sections of main memory by copying memory cell contents to disk, so the cells could be overwritten by new data. This increased the amount of code in the operating system. Hardware MMUs and extra software in the operating system allow you to swap entire processes out to disk and bring in other processes from disk. This combination lets you run many applications, each thinking it can use most of the computer's memory. When you add enough main memory, RAM, to a computer, several applications can live in main memory without needing to make room for others by being swapped out to disk.
So, to be honest, this virtual
Add
memory
enough main memory.
is not really critical to swapping. Swapping can be done without virtual memory. Swapping uses a mechanism called paging, which is kind of, okay, maybe it's related, maybe it's tangled to virtual memory, but it doesn't have to be in principle. Cool, so that was some kind of background. It's actually very nice because it's close to what we are doing right now here, when we have to kind of manage multiple processes and inspect their context process switching state. So those process descriptors, this is what we are getting when we call getRegs, this user extract. This is part of this process descriptor, actually exactly what is shown here. The full process descriptor is slightly larger, so we are getting just this part with registers, but the full user struct actually has a little bit more data. Okay, let's take a look at the next one. So this Livlo. This is, from what I heard, it's a platform for natural language-based coding. What is it? Not here, not here. Not here. Anyway, I lost it. Let's watch some videos here. I guess we can resume the music. So it looks like a language which is closely modeled on natural language. Actually, I heard, yeah, I've seen this mention of language models here. Yeah, this is actually very interesting that it's possible to, I'm not entirely sure, is it parsing this and actually emitting equivalent code? It looks like so. So this looks like an example where we have a piece of, how is it called, PowerShell, and a little bit of equivalent Livlo code. Do we have any audio here? No. Okay. So those demos here, the big problem with LLMs is that you have to give them all the context that they would need to solve the task. So giving them a plate with everything they will need to solve a problem. A lot of the LLM wrapper applications do exactly that. They manage the context that the LLM will get. So those things, LLM could probably even write classical programs to solve those problems. I think that the value here is some program that will kind of collect all of this context that the LLM would need to solve the task. So I think it doesn't really show the hard part of the problem, because the context, it must be there in this demo. There must be some context which the model gets, for example, about the structure of tables or just the environment we are working with. Are we working with a file system, with a database, with a REST API? What are we writing, right? This description is not sufficient to write any program here. So it probably lives in some kind of system with a database integrated, or a database and a file system, I don't know. It looks like a very nice language, very readable, like the evolution of SQL. And it appears to be commercial. So commercial programs or commercial systems, this is like a death sentence. Or maybe less so recently, because recently we see a resurgence of no-code app. I mean, once the buzzword was created, once we started calling them no-code, I think they became more popular. But in the past, when you wrote a visual programming language, it could survive, basically only if it's free, essentially. Because once somebody has to pay for it, then you lose a lot of trust. So they had a history of rug pulls or bankruptcies, and therefore just people don't trust those integrated platforms. And they often associate trustworthy languages with textual languages. So the people who, like programmers, like hardcore programmers who have been educated, who work at large companies, they typically code in textual programming languages, because textual programming languages almost always are open source, or at least they have open specification or multiple implementations. So successful are always non-commercial. And by non-commercial, I don't mean they cannot be used commercially, I just mean that they don't have an owner who kind of can decide how they will evolve. Or at least the owner is kind of gave up the control over the language. Because there are some like languages which are theoretically controlled, like Rust used to be controlled by the Mozilla, Go by Google, C# by Microsoft, and actually C# also suffered this kind of negative trust because it was owned by Microsoft. People didn't trust C#. This is less the case with Rust and Go because those companies have a little bit more kind of trust behind them. Yeah, so I'm afraid, yeah, it just happens. I literally have a page which is like a graveyard of programming languages, and this is the biggest determinant of whether a language is going to stay alive. When it's commercial, it's just not going to fly.
Marek Kowalski says.
But they open sourced C, and it's improving a lot since then.
Yeah. Since the switch to, I think it was from Balmer to Satya, C# suddenly gained a lot of credibility. Yeah, but my point is less so about textual languages. I see this issue all the time in visual languages, or like visual languages, which could be really good, but there is always a company behind them that tries to monetize them, and there's no way to trust a company. If you have something that you really depend on, like your own business, right? Investing into a language owned by some entity that may then decide to randomly extract value from you. It's just a very... You would have to have a lot of trust in this company to migrate all of your code base into some commercial entity, to depend on some commercial entity. So a lot of no-code platforms, there are a lot of interesting no-code platforms, but the biggest thing with them is I see all the time that they are developed in this way, which gives them kind of control over the code of users. There are more platforms like that. So some of them, like TL-Draw, for instance, this one is decent, this one is legit. This is a good example of how you should do it. This is a commercial enterprise, right? But they allow you to export this stuff as... I think they even had JSON. Maybe I was wrong. Yeah, but when you can export this as SVG, you can parse this. So you are not completely locked in. It's not a programming environment, right? But it could just as well be.
No code, you mean like Notion, any type?
Any type and Notion, I think they are more... I think they could be coding platforms. I don't think they have... I'm not familiar with Notion, to be honest. I'm familiar with AnyType, and AnyType doesn't really offer any coding-related stuff. But AnyType also has a nice development model. AnyType is open source, importantly. Right, so you can find them on GitHub, I think. And they are developed as some kind of co-op. So the commercial structure behind these companies, it also builds more trust, the way that they do this. Yeah, and they really go into buzzwords. So that's good. That's good. Buzzwords are, I'm afraid, necessary. Okay. Oh yeah, that was actually a demo of an app. So let's see how to use this. So I will turn down the music.
Focus on doing one thing at Hi guys, and welcome to the live demo of Custom Legal Docs. Custom Legal Docs is a company founded by attorneys for attorneys, and we focus on doing one thing at the highest
Okay, this is as loud as I can get in OBS.
level, and that is drafting your fully customized legal documents. Here at Custom Legal Docs, our software does not generate any text. We don't use any generative AI. All of the text that appears in
This is super important for legal documents. AI could totally mess this up. So yeah.
from your forms, your library of templates, your default and alternate clauses, everything that shows up in your document has been drafted by you, the attorney. Okay, let's jump right in here. So, at Custom Legal Docs, you will work with an attorney to fully customize your documents. What that means is you will tell that attorney which sections of a document should be dynamic, which sections are boilerplate and will never change, and they will work with you to ensure that every section of your document that you would like to be dynamic, meaning it can change based on...
Actually, let me pause. I just read your comment again about no code. No, by no code I mean something different. I mean there is a lot of platforms recently which allow you to code without using any specific programming language. This is probably... Don't pay attention to this. So no code is just the name of an idea, a general trend. Yeah, maybe Wikipedia is a better source. Zapier, yeah, I heard about this one. Make if this then that tray. Yeah. Those are actually platforms which allow you to build stuff using drag and drop and connections. Kind of similar to Automat, although Automat is not... It's not trying to be no code.
But I think Notion, any type, base row, Artable applies to no code.
I wouldn't say so. So we have to put a boundary somewhere. So no code has to have some meaning. And to me, this meaning is building apps, like building web apps, mobile apps, some kind of interactive experiences. I would even say that Excel is more no code, but for any type, I wouldn't say so. Any type is like personal wiki, or like not personal, it's like wiki, like a nice local first wiki platform. It doesn't have the interactivity. You cannot really talk with APIs or databases using any type.
on your instructions is able to do so.
Okay,
So the end result
but when you
is-
Google Artable, it says, Artable is a low-code platform to build next-gen apps.
So Airtable, maybe. I think I took a look at this a long time ago. Not up to date. Airtable, yes, it may very well be a no-code platform. Yeah. Sorry, I just looked at Notion and AnyType. I also don't know anything about base row. Yeah, I think Airtable, the whole point of Airtable is that it's tightly integrated in some kind of database that you can then operate on in your app.
Base row is open source Notion Artable.
So Notion. What is Notion? Okay, so I think that there is the feature that I think base row adds to the Notion model, where it introduces programmability. I'm not sure how programmable Notion is, really. Yeah, it looks similar to AnyType. It's like wiki, or like wiki plus some other data management stuff.
Notion is only programmable via API GINs.
Yeah, so the point of no code is that you can come to a business and tell them you don't need your programmers. Here is a new app that would allow you to fire all your programmers. Instead, business people can use no code to build apps for themselves. This is the value proposition of no code. To replace expensive programmers with just everybody in your organization. So the people who are doing some process-specific work, like doctors at a hospital, or people literally anywhere, or somewhere in the industry with or maybe not replace, but because it doesn't usually requires firing, programmers. But the point here is that no-code platforms, their value proposition is that everybody can program using them. You don't need any programming knowledge to do this.
I did some programming when I imported my watched movies list from Simple Platform to Notion via Nathan.
Yeah. The point is you automate stuff in no code. Okay, there is a lot of introduction here. I would like to maybe scroll to the point where we actually start doing stuff. So this whole thing looks like a web application to me. By the style, the buttons that I see here, it just screams it's a web app. So it also tells me that Livelaw is a web-based service where everything you build is logged into the platform. Exactly, the platform. The platform is actually a negative thing. So this is not, I know you have to advertise somehow, but no business wants to depend on a platform. Trust is a bad thing. It's better if you don't have to trust the platform.
Document that has been customized, you'll open up the program. It will look like this. The document you select will be here on the right. I have chosen an extremely watered down version and condensed version of a trust agreement because it's easy to illustrate. I also have certain sections highlighted here for your ease of review. This can be done in your program, so to help you see what is changing, it can also be turned off.
Okay.
And when you
We will see some examples in a moment.
it will not have these highlights unless you want it to contain those when you export it. So you see your draft document here. You will go over here, press this button, and this is the magic of custom legal docs. So in this command box, you will either type in your drafting instructions, or to the extent you have existing drafting notes from a client call or something like that, you can simply paste them in as I'm doing right here. Click draft. You wait a few seconds, and then right over here you will see there it is. It's done. So literally what I pasted in that box, what I pasted it in this box here, are the same drafting instructions, right, that I would send to a more junior attorney or a paralegal to draft my document. They wouldn't need to know a lot more than that. That's the bones, the meat and potatoes of it. The software has read that. It has placed it over here on the left side in what is called our structured text.
The current
So our
trend is that
software
offline
has
first
read
platforms
your
are being
instructions.
chosen over
It has
SaaS platforms
understood
due
them
to
and
privacy
organized them
concerns.
into a structured
People are becoming more aware of privacy issues and
that it
vendor
can then
lock-in.
use
Exactly.
and pull the correct and corresponding paragraphs and length
100% agree.
so it knows what to make appear and what to hide. right?
And the offline platforms, they are harder to monetize because what do you sell? Licenses? Licenses can be cracked, right? There's no way to know if software is used offline. Like, this is why literally everybody went from sold software, like software in a box, to software as a service like a decade ago.
Miller Family Revocable Trust, we have John Miller and Sarah Miller. We had a couple of specific bequests here, $750,000 to Brad Smith and $250,000 to Jen.
I think the interesting thing is that in the instructions there is a mention of alternate trustees here, which is not mentioned anywhere here. So, and this actually shows maybe this is the fault of LLM, which forgot to include Santa Claus and Easter Bunny as alternate trustees.
Jenny Robertson, we had a gift of real property here to Ethan Jones. We have some trust created.
Oh yeah, actually they are mentioned here.
Then as our successor trustees, we had Santa Claus named to serve, and if Santa fails, then we have the Easter Bunny named to serve. Because we have those trusts for our children, they're able to elect to serve as co-trustee and then eventually sole trustee, and they're able to elect to serve as co-trustee at age 30 and sole trustee at age 35. And finally, we allowed any trustee to receive compensation under our instructions. So let's make some changes and really show you how the software works. Now, to be clear, here on this left side in the structured text, you can make any change you would like directly from that left side. So for example, if you want to change, if it wasn't Sarah Miller, you change it from Sarah to Beth Miller, you can do that, and then bam, right here, there's Beth Miller, okay? So you can make any of the changes right here. I prefer to use this button because it demonstrates the power of the software. So what I will do is, let's say we'll make a quick change.
Okay, so this is like forms.
We don't want these. We don't want these gifts of cash. Go over here. Boom, boom. Take that away. Gifts of cash are now gone. You'll notice that this gift of real property was section 2.3 when we still had the gifts of cash. Now that the cash gifts have been deleted, the gift of real property is section 2.2. That's important because it demonstrates that the software maintains your formatting. So however you have your documents formatted in Word, that will be maintained.
Okay, I'm just
throughout the software.
scrubbing here through the video to see if, because I'm interested to see how this is actually built using Livelo, right?
This is what it looked like before. So this will be like kind of what your
What's the code behind the scenes,
customization.
not a demo of.
So we have Santa Claus, and if Santa Claus. Another thing I should mention.
Okay, we are not lawyers.
The grantor,
This is not interesting to us.
whatever you download into the About section, you can scroll down right here if you put your info.
Okay. So I see this is an example application created using Livelo. Yeah, I really hoped for an explanation for how this actually works. And those explanations here, those videos, those demos, they don't show the product at all, kind of. Okay, let's continue. Next, we have a repository by Bill Budge about function charts, a graphical programming language. This is, okay, sorry. Adjust the volume. Now, this is a wall of text. We can see an example of a state chart. I will use a TTS actually. I think there was a way for me to access the all talk. There we go. Speak a nice voice. I'm not sure if it's not going to be too much. Let's try it.
Function charts are a graphical programming language using a node and wire graph to represent programs. This repository contains the source code for a web application that runs in a browser and can create function chart graphs. There's no support yet for compiling, executing, and debugging these programs, but that would be a good project. The emphasis here is on the design of the language. The web application is currently just a very specialized diagram edit. Function charts are inspired by state charts. Flowcharts would have been a great name for these, but that name is taken. The function chart name is also taken. Many node and wire programming systems have been built, however. Most are either domain-specific or are targeted at non-programmers. The audacious goal here is for function charts to be equivalent in expressiveness and power to conventional textual programming languages. Like state charts, function charts use hierarchy and abstraction to increase the power and economy of the notation. The two principal innovations in function charts are: functions can accept other functions as inputs and produce new functions as outputs. This gives the diagrams much greater expressive power. Functions define scopes, and a function can be used inside its own scope. This allows us to naturally express recursion and iteration. Function scopes can be nested and may define complete functions or partial functions, allowing us to create closures. These two features can reduce the visual complexity of the function chart diagrams by making it easy to produce and consume functions. They can also organize the diagram, reducing the number and complexity of the wires. Here is an example implementing the exponentiation by squaring algorithm.
You seek
This example is
inspiration
generic,
for Automat?
applying to any type where multiplication can be applied, e.g. numbers, complex numbers, polynomial.
A little bit. This is just something I'm kind of interested in. So this could be an inspiration. There is something new about function charts here that I haven't seen in... There was this other very similar visual programming environment, or music programming environment. Yeah, potentially inspiration. I think this is just, there are just so many interesting projects on Future of Coding that I wanted to show some of them, and maybe some of them could be inspiration for stuff that we could do in Automat. State charts, for instance, state charts are very easy to implement, so they are drawn like that. They don't look exactly like that, I think. There is a notation called state chart, which looks slightly differently. Yeah, that Automat could have. So the innovation of function chart about including functions. Sorry. Including functions as inputs. This is interesting. And in all environments like that, I'm always interested in how they handle loops, because loops are actually the difficult element of those data flow environments.
It reminds me of automata and state machines from university.
Yeah, state charts are a lot like that. This is... I probably have to look online for them. Sorry, so maybe this is something else. Let me quickly check what's the name of the programming environment. Pure data, yeah, that was the name. Pure data is super efficient, but it's also kind of hard to learn. You kind of need to know how this stuff works to use it. But it's cool. It emits a very efficient machine code. It uses your hardware well. So this reminds me a little bit of pure data. Let's see how it differs.
Polynomials and matrices. A specialization of the generic function for numbers is on the right.
Okay, so I see we have inputs which apparently are not typed, or maybe everything is an integer here. So we are comparing n with 0. If it's 0, we are calling an if check, which is going to select one of those numbers. Okay, so this is a visual language that doesn't really take advantage of the visual part. It should actually show. So I'm kind of guessing this is an if condition. I'm probably right? This is probably equality with 0, so it outputs Boolean. I think a lot of those things could really be shown here. Okay, so the function calls itself recursively. So here there is a recursive call into X step. Oh, I see. So it actually can take a function as an argument. Here, you want to do exponentiation, and when you want to do exponentiation, you sometimes want to pass your own multiplication function, because you don't always want to multiply numbers, at least not always integers. Sometimes you may want to multiply floating points, or polynomials, or matrices. So this ability to inject a custom function as a multiplication in a visual language, this is nice, this is cool. So it's like a different type. It's shown, instead of being shown as a small rectangle, it's being shown as a rectangle with other rectangles inside. That's nice. Okay, that was cool. Simple functions. Okay, they also mentioned closures. I'm also interested in how closures are defined, because if you want to define closure, you have to put some variables into this outer function that the inner function is going to use. Let's see. So we have no recursive call here. This is just a function with some arguments. Okay, and now this is a closure. I see, yeah. Because this is a function that refers to external state. And that state can be mutated. Okay, this is a cool notation. I think this could be turned into a nice this could be the foundation of a visual programming language. There is, like I mentioned, it's a visual programming language which isn't using any the powers that being visual gives you. It's just black and white with a little bit of text.
Isn't Automat assembly widget visual programming language?
Yeah. And the language, I'm not sure if the language is actually necessary there. I would rather call it system. Because language implies that you have to learn a syntax and that you have to learn vocabulary. So essentially you need to know how to compose, text to create working programs, and what are the words that you can use. And in a system like Automat, you don't have to learn them because the system kind of guides you through this whole process. So it gives you a library of instructions that you can use. And when you want to pull a connection, it will actually make sure that you can only connect to other objects where you can connect, where the connection makes sense. So there is no way to have syntax issues, and you cannot really forget how to use it. It's just, you don't have to learn it. I think that's the big difference. I think the thing about languages is that you have to learn them before you use them. And they have kind of formal nature. Yeah, but absolutely, Automat is visual programming. And Automat is multi-paradigm, so it has elements of this flow-based programming. I mean, we could pass messages through connections. We don't do, but we could. But it's also stateful. I mean, there are also pieces in Automat which do the math. They are more like constraint programming. So there are also like other pieces here that use different paradigms, programming paradigms. So Automat is not a pure environment. It doesn't take any approach to the extreme. It tries to be practical. Okay, I see this is a pretty deep rabbit hole. Okay, I am studying this. I think we should take a closer look at function charts. So there are some things I would like to see that I don't really see here. One of them is how do you actually create them? Do you create them by writing code and the diagram is created for you, or is there a graphical environment for creating diagrams? How does it work? I would like to see somebody using it. This is, I think, what I would like the most. And there are so many... Okay, check some. Okay, the editor, I guess it's still being worked on. Oh, I see, this is a palette of commands. So I can grab stuff from here to create new functions. Hey, that's nice. Some checkboxes. So personally, I'm not a fan of those pop-up menus, those inspectors that come up when I select different things here. But I guess it's probably the easiest way to solve this problem. Yeah, I wanted to delete the toolbar. Let's write a function. So let's give it an argument. Let's call it x. I just want to see if I can create a factorial function myself. And then we will call this function.
I wonder what would be your approach for those pop-ups.
This is actually the hard problem of UI. So there are a couple of things. I've seen some cool solutions to this in the 90s. So there is Workshop Widget. Sorry, Widget Workshop. So this is a cool application which actually used this fun approach of, so to edit a text field, right? For example, if you have a text field, you would have to create an object that allows you to edit this text field and just put it over a text field. And then you can use this to edit this text field. Sorry, text field. Let's say there is a label which is not editable. So you create a label editor object that can, you know, when you put it on a label, it allows you to edit this label. So this is one way to do it. And I kind of like it. I think it could be very intuitive and it would produce very clean user interfaces that would still be very, very editable. So this is one thing. Let me put them here. So this visual tools, example of this. And the next one, which I actually see quite a lot, is swapping between frontend and backend. So you essentially group a lot of functionality and hide it in a nice UI, but then you can open it and close it. So like open, close. This also covers zoomable UI.
What about some edited like in LibreOffice program, which opens on the right side of screen?
Yeah, the inspector approach. So the reason I'm not a fan of the inspector approach is that it is not a recursive solution to this problem. By this I mean, let's say you have a widget, right? you open an inspector to edit it, and that inspector itself cannot be edited, in return using the same way. So it's not self-similar. It's not what's the term? Isomorphic. I don't know how to call this. Yeah, and the same can be said about those open-close UI or zoomable user interfaces. They are also... Okay, maybe they could be recursive. Maybe they could be, yeah. So I take this back. But the visual tools, they are very naturally recursive. So for example, if you have a tool that allows you to, do something with another widget, for example, change its color, you can also clone this tool and put it on top of itself. So the tool will kind of modify, one tool will modify another tool, So you can chain them nicely. It has a lot of nice properties, this approach. And I think it's also very intuitive. So somebody who has no idea how this works and learns, oh, this is a tool that allows you to, for example, edit numbers, it will be very easy to use this. Yeah, so you don't have inspectors. So this is an old game. It's a cool one. There are some videos on YouTube which... So actually, maybe not the Widget workshop, but I think there was some related environment.
Edit pane.
Yeah. I think maybe author of, I don't remember exactly, maybe author of Widget Workshop created some other, let's say, more academic environment in the past. So Widget Workshop embodies like the spirit of this tool, but the original tool was something different, if I remember correctly. I don't recall the name. Maybe I have it in my bookmarks somewhere. I would have to... Alternate Reality Kit. Sorry. Yeah, this is the one. This is the one. Yeah. So yeah, to actually switch something off, on or off, that can be switched on or off, you have to create a switch widget and you just drop it on this thing. And now you can switch it on and off by, pressing the switch.
Scan the message. The button is made to simply fall through. And find a slider.
So you kind of... This is not super extensible because each widget is just a rectangle which lives in like some fixed space and they have to be like literally connected together. But I think this basic approach could be extended to offer this inspector-like functionality without any inspector necessarily being there. Yeah, just visual tools for doing all of this stuff. And inspector itself actually could be one of those tools. So there could hypothetically be like an inspector object that you can kind of put, like connect to other object that would then allow you to edit it. The big difference between the edit pane approach and the visual tool approach is in the visual tool kind of world view, the inspector or edit pane is one of the tools. And in this edit pane approach, which most software actually uses, you have a global, like, properties panel, like to the right or somewhere, which allows you to edit what you currently selected. Okay, so I will attempt now to use function charts without learning how it works. I think this is actually the more interesting. So for the author of this system, for Bill Batch, it's actually going to be more interesting to see how people kind of use it without being taught how to use it, because this is the selling point of visual programming languages. Can you use it without being taught the right formalism? So let's rename our function into Fib, because this is the Fibonacci function. So when I drag it here, it's not what I want. This kind of makes this function an argument of itself. I don't want that. Maybe I can somehow drag it. Again, some weird things are happening here. Okay, I think it works now. But no, this is the output of the fib function. Come on. Yeah, I don't want the fib function to be parameterized. Like that. I see the way to call a function is to call a rectangle like this one. So this is a fixed value. No, I don't want that. So this is anonymous function, which takes a fib function as an argument again. So those are basic operations. This, maybe this. No, doesn't seem like. Honestly, this looks like a recursive call. How do I do recursive calls? Yeah, the function should have itself as a rectangle inside. But when I try to do this, it creates a... Okay, actually no, this is good. This looks like a proper way to do recursion. Let's call this XM1. Here we will have XM2. Actually, no. Just X. Keyboard shortcuts. I would like to see some keyboard shortcuts. So let's put constant here, another constant, if2. We will subtract. Okay, this is negation, so this is not what we want. I can just make this -1 or -2 here. Okay, I see this is a very minimal environment because instead of subtract, it has negation. It really tries to offer you just the minimal blocks that you might need. To work. It's okay. So we are computing Fibonacci of this. Let's add an output here. Another recursive call. Another addition. Oops. I have no idea what's happening here. I will delete those things. So I want to now subtract 2 from x. It should be possible. I see it's possible to create connections that go multiple ways. Is this what I have to do? No. Now I have 2x arguments. Oh? I think we have been there for a moment. Yes. Okay, it's just very fiddly. The drop targets are very small. Okay, now we can compute the Fibonacci of those two numbers, add it. Okay, and output this. Cool. Now we should be able to call our fib function with some value. Let's say 5. Now, how do I print it? What is this? Okay, I don't see this component used anywhere here. Maybe it's a comment block. So what is the output number? Let's see what values do we have here. We can have just the end of a connection. Actually, I have no idea what this is. Some kind of select, maybe? So this stuff I can delete. Let me open a new tab with this editor and let's load some example, maybe something that prints a value. Okay, I can convert this to SVG. Oh yeah, there is an example of Fibonacci. Oh yeah, I didn't put any stop condition. Yeah. Okay. So it will actually print to console. Will it? How do I run this? None. Nope. Okay, this is for selections. Okay, I see the editor is work in progress. So what I like about function charts, and I will probably take a deeper look at how specific things are solved here, is that it's very complete. It seems to handle a lot of the edge cases that flow-based programming typically has issues with, like loops, like capturing the state, like taking functions as parameters.
Kukapepsero says,
All the song names XD.
Yeah. It looks interesting. So I think it would be, yeah, the editor could be improved. It could have more obvious tools here. Like one thing that surprised me was lack of the subtraction operation, which I guess is done like that. The ifs are also, I don't know how to properly handle ifs, but there could probably be like a better representation for this object. I'm also not sure how it's computed. Is it computed in a pull function, pull way, or push? So that if I have a condition that checks A or B, I guess it has to be pull. Because a push model, computation model, would have to compute both branches. Like all of the branches would have to be computed, and then the if would make a decision which to kind of propagate further. But if we have pull, then we can first compute the condition, and then, depending on the condition, we decide which branch we want to kind of compute. So I'd have to add some kind of comparison here. I don't see any comparison objects, unfortunately. The library of functions, this toolbar, is actually a hard design problem, I would say. How to do this in a way which allows users to, at a glance, see what options do they have available, that make the options clickable. Because I see an issue here is that a lot of the things are very small and finicky. There is no hover feedback when I move my mouse. So I'm not sure what my action will do when I click stuff, right? When I click stuff here, it pulls the whole object, but if I just move it like a couple pixels left, it will grab this. Same here, when I want to grab this object, when I grab on the left, I will grab the object. Just a couple pixels to the right, I will just remove the connection and create a new object. Yeah. There is a lot of kind of touch interaction optimization here. That's nice. Oh, I see, this is just a placeholder. So the less than is just a placeholder function which doesn't actually do anything, I see. But some things which are done very well is that this function thingy, it's very intuitive that you can just grab the function name to create a new copy of this function, new instance of it. This is nice. I don't know why it's using dashed lines. Cool stuff, definitely worth following. Just 1 star. Crazy. Yeah, it's like, I feel that some people in the future of coding community, they mostly focus on the front end, right? So they have really decent like UIs for editing this stuff, and some people focus on the backend. And this screams to me, this is backend focused project. So the computational model is very good. I mean, I don't know how it would behave in edge cases where, I don't know, you run out of memory or this kind of stuff. Or when you have to process external data, like real world programs, I see them being written here. Visual presentation could be more readable, could use the visual aspect a little bit better. Okay. Okay, I have to put a stop to this.
Nice self-control, Darachu.
Yeah, we kind of have to switch to the stuff that we were going to do today, which is our assembler widget. Oh, ptrace failed. Nice. So it actually crashed after some time. So I left this running. It was just incrementing this counter in a loop. And now I guess I still have a thread. Actually, I don't. So there is assembler thread still there, it's just stopped. So there is a bug in Automat right now, where it probably just stopped. One of the operations failed, I don't know what happened exactly, but it failed and it just didn't resume the assembler thread. Anyway, I can just close this. Cool. So we want an assembler widget. I've been thinking about improving our assembler model. Maybe we'll look at this next week. This week, like today and on Friday, I would like to do as much as we can from this object. Okay, our widget here is not going to inherit from fallback widget anymore. It's going to inherit from GUI widget. Okay, width, how wide this is. It shouldn't be too large. Let's say the assembly is going to be 5 by 5 centimeters. Actually, we don't need this width function, we just need shape. Shape, draw, and find action. And name.
Mood and a thrubbing shrubberies.
All of this music has prompts attached. So if you look here, actually I don't have prompts for those. But in those directories you can see what prompts have been used to actually make those tracks. For some of them. I'm afraid for those I don't have the prompts, but they should be similar to different error every time, something like that. Okay. So I will put the widget code at the end. Yeah, this is good. Okay, this is the decent first go. Let's introduce some constants for the shape of this widget. I think it would be good to define those constants within the widget.
I was perfectly fine thinking you wrote those.
I mean, in some sense I did, right? Lyrics, right? Lyrics, I wrote the lyrics. Okay, when we have this shape, we should think about where is the origin of this shape. It's going to make some things easier for us. A well-defined origin. I think center. I think origin in the center of the rect would be nice. Okay, I don't have any factory functions for rounded rectangles. What are the types of SKRect, erect? Let's call this make simple, because it uses this simple type from Skia. What is the issue here? Oh yeah, I see. And this is a factory function. I can make them actually the same. Let's put a variable here. So probably even those variables are not necessary. I mean, they will be inlined by the compiler, so I can keep short names here. Okay, now we can start drawing this thing. Let's first draw a zoom in. How does it look? So it has a darker outline and slightly lighter inside. This border here. It would be nice if we could use smooth gradient on the edge here. So I'm not sure how to draw this. Okay, I will comment this out temporarily. And I just want to create some assembler so that we see some example when Automat starts. Yeah, there it is. There is our assembler. It's very small. Maybe that's good. Maybe that's okay. We could always make it larger. I cannot drag it. Let's implement the dragging. Now it should be draggable. I think it should be larger. Let's try 8 centimeters.
Knight says.
Hey everyone.
Hey, Knight. So there should be enough space here for registers. This is all I want. Now so there is this thing for drawing double rounded rectangles. Let's create outset. Yeah, this is the function I would like to add there. Okay, type. I think this type has to be changed. I could say complex type, but really close this if condition because it messed up everything. Actually, no. Okay, so we have oval, simple 9 patch. Otherwise it's complex. Cool. Oh, yeah, C++ actually, so the official standard of C++ doesn't allow aliasing. So when I write to this union member is inactive. But I think there are no const exp functions here. So I'm afraid I cannot really access those fields. Oh, actually that's good I checked, because it's actually not doing any checks. Okay, 9 patch has, I think, equal some of the values there have to be equal. So if so this lower left it should equal lower right dot y. And now the x coordinates x should equal left, the last one. Now it's a 9 patch, otherwise it's a complex type. Okay, that should work. I'm implementing those const expr functions because I really like rounded rectangles, and especially outsetting them, so making them larger and smaller. I think this creates... It's easy to create really nice effects using this way. I don't see what I would like to see. Yeah, that should be negative. There we go. I like because those circles, they start at the same point. Let's grab this color. Cool. Now we will have beveled border. Actually, the color of this should change, but let's look. Let's use a temporary middle value. Okay. And the inside of this thing should be drawn. Actually, it's pretty decent the way it is displayed here. Inside we will have some stars. It has some issues. Maybe you could disable anti-aliasing or enable or disable. Let's try disabling it everywhere. So the issues may also be caused by tessellation. It's possible that tessellation is handled differently here. I think it's slightly better, but this is not what we want. So let's disable anti-alias. I think by default it should be disabled. And what I will do here is I will just grow this a little bit. I need to know how large is 1 pixel. So let's grab total matrix, invert it. Yeah, maybe we can do that. So actually this tells us about 1 meter. Like 1 meter, how many pixels it is going to have. So I think we should divide this by 100. This divide by 100 is probably too much. Yeah, we wanted to have meters. So this is 1 pixel in meters. So the reason I am doing this is that here I can do, I would set 1 pixel. So now there should be no white line around it. Okay, I guess we could draw these stars. Let's look at our design. I mean, there are so many subtle things here. So many, like this black line, for instance, here. It's not actually a black line, it should be just a shadow, like internal shadow. So there are two ways to draw stars. We could either draw them as a bunch of circles, or we could have a shader that draws them, or we could even have a texture. This is yet third option. Shaders are, I think for the hardware, are the easiest, but they have the compilation cost. Actually, let's just use Skia facilities for everything. Let's draw 100 stars. Okay, star is going to be just white. I think this can be initialized. We'll use the default initialization. I think those stars, it would be nice if they created this effect of being, like, we have stars, great, this effect of being far away. So I think they should be drawn in the screen space, not in the space of this object. I think it will be easier with a shader. This effect that I want to get here, of stars being kind of attached to the screen. Okay, let's use this one. I will just use the same method as here to create the paint. Okay, let's include global resources. Include embedded. Now we can start working on our shader. This will be in assets. The color was, what was the value of this color? It was something like 23. We have no uniforms. Assets. Let's try to compile this. Cool. So we have our nice color. And we have a local coordinate. Is there a way to access screen position in SKSL? So there is this trick which could tell us the size of a single pixel, but that's not what we are interested in. We'll have to create a proper uniform value, possibly for the screen matrix, so that here we'll convert the UV, the local coordinate, into a screen position, and we will use that to draw the star. But let me do a short break now. Actually, not so short. I will grab a lunch. See you in a couple of minutes. Okay. I'm back, so let's continue. What I think we should have here is a uniform matrix 4 or matrix 3. Essentially that. So let's go back to our builder and let's call I think there was a way to get current matrix. This will give, okay, this is this deprecated version. This is exactly what we want actually. Get total matrix. Thank you. We can actually even do this so I have changed the value. Okay, it's going to be white. I should have divided it by something. Let's divide this by 1000. I have to zoom in and out for this to redraw, because now the position of this on the screen, this is actually problematic, because the widget, the appearance of the widget depends on its position. Let's see if I can invalidate this somehow. Okay, this is actually a hard problem. This is a type of widget that doesn't really fit my rendering system. Because now it's rendered to texture, I move it around, and here it should be red, here it should be green. If I zoom in and out, I can do this smoothly, as long as I'm zooming. But when it's there, it caches the texture and doesn't redraw. So what are the workarounds? We can just constantly invalidate this widget. I think it would be nice. So this is not super efficient solution. We could also have a new handler, like new method in the widget, which would be called when the widget moves on screen. And that could be invalidating widget.
Low cost effect. Okay, so if a widget is off screen, we will not render it even if it's ticking. So the first approach wouldn't be, that terrible. It would be just a little bit terrible. But I think we can actually do the drag notification. So let's look at our drag location action exactly. The update function. I think here we could call some method of the widget to indicate that it's being moved. But the thing is, this is a different kind of movement. So each object, each location in Automat actually has its up-to-date position and the animated position, which smoothly animates between whatever is on screen to the actual the target position where the widget should be. I think so this tick here, this is what animates the position of the widget. Yeah, this state.tick. Yeah, I think we could do it here.
Okay, let's iterate over child widgets. Okay, now we can go to our assembler widget and we can use this function to refresh the texture. Yeah, I think this is the correct way to do it. Nice. Now when I move this around, it re-renders. And it's using all of the infrastructure that we have elsewhere. So it's like a window now, right? We can see this gradient space behind the assembler widget. Now we can play with the shader. So we have pixel coordinates. I would like to get a random number. Sorry, not random number. Let's divide this by 100. I think just converting this to integer, that should do the trick. Or actually no, it doesn't have to be integer, it's fine if it's a floating point.
Patrick Dreverstedt says,
Good afternoon. Hope that you are well today.
Hey, thanks. Yeah, we're doing something pretty cool. We're doing the assembler widget. So we are back to graphics programming. It's going to be a strange widget. I have this thing. Yes. I mean, ignore the red lines. We should hide them. They should not be here. They should not be visible. The reason they are here is that this assembler widget is actually, this is the object that looks around. It finds all of the instructions which are nearby, and it serializes them into an executable block of memory. This block of memory can then be controlled from buttons that we will have here. The connections should be implicit, so they should not be visible. And once we are done, it should look something like that. It will point to the currently executing instruction and will show the values of register and have some buttons to pause and to change the state of this widget. Pretty much. Oh, and we are coding with LLMs, so we can there is actually a way, so if we just draw the kind of in the most obvious way, where we just take the current grid index, we randomize position, we draw a circle, the stars would look very irregular. There is a trick to actually fix this. And the trick is that we introduce overlap. So each grid position will render a star, but not within its own rectangle, but within itself, and let's say one to the right and one to the bottom. And here, when we are calculating the value of the pixel, we have to consider it from the opposite side. So for a current grid position, we also have to identify grid position before, like above and to the left. And for those grid positions, draw the stars.
Knight says,
Hey, Patrick Drevestet, your project on GitHub looks really great. Would it be possible for you to set up a live demo?
Let me check this out. Which one is this? Is this... I just want to check this out.
GitHub is among those who follow you.
I don't think I see followers or anything like that. Actually, no, cancel. This is the file I want to change. So this type of shader is very popular. It's possible that LM is going to do this for us completely. Okay, it's thinking, I guess.
You have 69 followers, and Patrick is one of them. Tab followers, LRT.
Interesting, so probably because of my scaling, I didn't see this tab. It's actually hidden. Huh. Repositories, new. Yeah, so it's a website. So I love Django, by the way. This is my favorite web framework. One of the few ones that it really embodies the Python philosophy, right? Doing stuff for you in the most kind of minimalistic way. I see lots of comments. Actually, this is a very nice code. Okay, star radius. Okay, this is strange. Okay, it's using star units. 5 pixels is a lot. Okay, and so this is actually copy-paste from a different algorithm. I specifically said that I want to have a 2x2 square, but it's using 3x3, because most people who implement those shaders, they use 3x3. It seems more symmetric this way, but we don't need symmetry. Yeah, so this is actually funny because I instructed the LLM to do something that deviates a little bit from the way this is typically implemented, and it implemented it the classical way either way, and the difference is tiny. You just change the starting index to 0 here. Grid is the floor value, yeah. Okay, it did some adaptation. There is some basic adaptation here. Let's access this. I mean, we have stars, so there is that. It's just... I think here we should take minus. This random was the... Okay, it's from 0 to 1. Yeah, I think this should be good. Now I want a slightly different anti-aliasing. Looks good. So it's not perfect because it cuts off some stars, but you can fix this if we multiply it by two minus star radius. Now stars should not be cut off. And this behaves more like a window. I don't like that the stars are so smooth. So there should be more of them. Actually, when I do this, I should also call this transform changed. I will do that. Okay. What is up with this move camera action? Yeah, I see. It modifies this move velocity, and I guess it's used in a different place. Yeah, to do the shift. So there are a couple situations where I change camera position. There is a touchpad. And there is mouse movement. Okay, it's not smooth, unfortunately. So when I grab this object and I move it around, you can see that the stars are staying in place. But when I move it like that, there is a 1 frame delay. It's very subtle, but it's there. It's a little bit jumpy when I do it like that. So I grab here. They are absolutely fixed. Nothing changes. And here, yeah, they wiggle. I don't know what's the way to fix this. I will have to rethink the rendering, the frame packing probably. So that the tick function should be called as we pack the frame, not at the end. Well, let's go back to the shader. Okay, I will again try the language model, because maybe language model will
everything's the same. Pixel, I think... No, Pixel is still here. Let's try the apply. What is this step function? I'm not familiar with this one. Okay, this is not exactly what I wanted. I still want slight anti-aliasing. Yep, I think this should be good. I think I would have to do a screenshot to see if the anti-aliasing is correct. Let's see. Yeah, looks nice. Now we can tweak some parameters. So instead of fixed size stars, star radius is going to be a random variable. Yeah, looks good. Cool. The stars now have varied sizes. There could be more of those stars, and I think they should be smaller. Cool. I will just see if this refactoring didn't break anything. Cool, it didn't. And now we can decrease the grid size. Let's make it 50 pixels. Pretty nice. Cool, now we have this field of stars, just like in our design. Our design also has this slight blue center. It adds something nice. There is one more thing I could do. It's that when we compute the distance, right, this length function, there is actually, it's possible to use a different exponent here. So instead of 2, we could use a higher exponent or lower exponent. Do I have to do them separately? This should give us our stars, but I think if we fiddle with this, we would get, okay, let's make them larger. Let's add something like this here. Yeah, so the stars are circles right now. If I turn this into something like 5, no, weird things are happening now. Okay, maybe because it's not an even number. Let's try an even, like 4. So now we are getting a shape called a squircle, which is almost a circle and almost a rectangle. Let's do something less than 2. Oh, it has issues. I think we have to do the absolute value here, because the negatives, they are just messing with the shaders. Okay, if I do 1, which is no, it means we are not raising this to any power. The stars are shaped like diamonds. And if we go lower than 1, like 0.8, they should actually be star-shaped. Yeah.
just an interesting tidbit. And I think this broke our soft edges. Will this make it smooth again? Yeah, I think they are smooth. Also, I think the star center I think we could round it so that it... Okay, I don't want to complicate this too much. We have pretty stars. This is what matters. Okay, what else do we want? We want registers, right? Let's display a register value in here. So I can delete... No, I cannot delete this. It causes a big crash. So I can create a loop, and I think this loop should be running. It's not running. I broke something. Let's do the registers. So this function that we had here it locks an object and just emits this text. we have this struct which contains all of the registers. So this is API like any other. I should probably have some. So I want to change this API. This is why I'm not paying too much attention to how this works. We just want to have a nice widget for now. We will clean this up in a moment. So we are drawing our object. After we've drawn the background, let's grab the registers. This is actually a good point. We would no longer be const. This doesn't feel right. So we should have a tick function to calculate this. I just don't want to complicate this widget too much right now. I'm just wondering, why am I using unique pointer for this? Maybe because I wanted to hide the implementation. Hide the number of registers to make it a little bit more like generic, not architecture specific. Okay, let's try this without the tick function right now. We will add this in a moment. Let's just do an object which immediately shows how immediately shows the state of the assembler. I think it will also make it easier to animate these things later. Okay, so the first step is to get the number of non-zero registers. Actually, this is not exactly non-zero. If a register has a zero value, we sometimes also want to show this if it was shown before. So I will do it differently. We have these regs, right? I think each child register could be a separate widget. This would be nice. What a terrible API.
So it is a terrible idea, but I think it might be necessary. No, it shouldn't be necessary, because widgets are only used in the UI thread. I actually think this would require us to drop the shared pointer entirely. Anyway, we need to implement this method, fill children. Nice warning. And we should probably call this not GUI widget, but base widget, something like that. Okay, that was a big rename. And I think I can take it out. Okay, a register widget is going to have a pointer to the object, so this is the assembler object. It will obviously have to implement all of those. No children shape.
let's say they will be 3 by 3 centimeters. I think each register should also also store which register it actually is. Now we need to implement the draw function. Okay, right now each register widget is just going to be rendered as a black rectangle. Let's actually populate this array when in the constructor. I think now here in our draw function we should actually call draw children.
Oh yeah, here, we forgot about this. So I am copying those shared pointers. It's kind of necessary because we need to keep those objects alive. Okay. So this is going to be our checkerboard. This checkerboard. It's interesting that I cannot really click this. Huh. Find the action should return a null pointer here. For object which doesn't implement this function. Okay, so we've just implemented this walking where we can follow the chain of widgets up. So if some widget doesn't handle an action, we will just search in a widget above it. So we can grab by this position and it will grab the whole thing. Okay, I think this shape should really be slightly different. So I will make this basic shape right now. Here. But shape of the object should really be larger because our registers should have the register icons on the top and some helper indices on the right. And I was also thinking of text fields below them so that the value of the register can be set directly here. Okay, now the shape is much larger. It's about this size right now. But this just provides us bigger canvas, more space to work with. Right now it's transparent, so we cannot really see anything here. But it's there. It's being drawn here, at least. The texture is larger. Anyway, let's draw our checkerboard. So I think we will draw this using this color here. And light paint, I think light paint is just white. It's almost white. Okay, now we need to divide this inner rect into 8 smaller rectangles. And I'm drawing from the bottom, so from 0 to 63. Actually, I could define this in a more readable way from the opposite direction. So float Oh, nice. It actually managed to figure out that we want to swap bottom and top. Cool.
I want to see if we have any checkerboard now. Almost. Nice. Almost like in our design. Yeah, it was off by one. Okay, there are 3 more elements that we should add here. So register icon, byte values on the right, actually 4. So bit positions and flags.
actually wonder where to store the data. So I would like to show the flags right now on the right bit positions. So hypothetically, if we have a piece of code that looks like that, get rid of this. I can run it. So in theory that should run now. It doesn't run because something is broken, something is always broken. But theoretically the value of the AX register right now, it should be higher. It should be set to 1 or something like that. And this is very interesting. Assembler should not return here. So I'm just removing all of the instructions that we don't need, that would just confuse us. Now I will create a loop. I think I know. I think this machine code might have been just not updated. But okay, when I connect it here, run it now. Okay, it returned 8. Okay, you don't need to wait for child to exit. I need a faster way to delete stuff. But anyway, so this can finish. Right, it returned 8. It returned 8 because this is the offset where we finished. There was a 3-byte increment instruction and then 8-byte call instruction. So in total this gives us pointer 8. So at instruction byte offset 8 we finished. So this is what it says. Assembler returned 8. So it should have incremented the AX register. Curious, segmentation fault. It's probably due to the way we manage those. And this assembly thread. I should isolate Automat from this. I should probably create a tiny library that would take care of the sandboxed execution. I think I've seen this. I think this used to happen when we jumped into uninitialized instructions. Okay, just for testing, for debugging, I will set the value Do I have anything in regs, actually? Huh. Okay, it has some value. We are actually feeling this. Okay, so I have some random value right in array X now. Now we can draw it actually. So we are going to need the flag icon, this icon here, and we will do this as a vector image, obviously, because this just looks nicer. Let's see, design regs. Let's check this. Not quite. And there we go. So this is the shape that we want. clone. Okay. So this is our flag object. And it's a clone again. I'm actually curious, can we see the XML? XML editor. And there it is. Look at that. I guess this is a decent shape. I don't want to mess with these scales right now. Okay, this is our flag shape, I think. I hope. We will have to scale this. There is no question about that. Okay, this is actually for later. So here we should really check if this bit is set. So we need to get registers. I'm not sure if this is what we should do. Dynamic pointer cast, come on. Maybe we should. Okay. I think this should work. Okay, so this way we are getting the value of the current register. Actually, let me go to the regs struct. basically this. So this will save us some pointer magic below. Okay, this is not exactly what I expected, but I guess that's fine. It's going to be drawn at the wrong position, so we have to fix that. Actually, it is not drawn at all. So what is the register value now? This looks fine. This looks perfect. Okay, it's not drawn, I know why. It's because those values are just crazy high. We have to scale this. And rather than using cell paint, let's use pole paint. Sure. It can be black, that's fine. I think this is still not enough. I should probably scale this even more. Oh, or not, it's here. So I exaggerated a little. Let's make it 10 times larger. I wonder why this flag is positioned like that. I could like subtract 100 from here and from here. Or even more. 70. Exactly, it is a little bit strange. This this initial offset. This initial offset is kind of weird. Manually editing SVG path. I guess it works. I think it would be nice if the origin was exactly at the bottom or maybe at the center of the flag. Maybe at the bottom. It would be nice if we aligned the bottom of the flag with bottom of the cell. Okay, I will grab those values, put them here. Okay, I need to translate x by 3.5. And 0.7. So grab the other path.
that was wrong. That was wrong. It should be negative 0.7. But there is one, like just one place which I have to change. Okay, beautiful. We have our flag at the perfect position. Okay, now fix the scale. Okay, I think the size is perfect. Yeah. Nice. Okay, pretty much. This actually looks exactly... So this is 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Here are our register values. And I think I could actually make those flags wave. That would be nice, right? So I think the idea when I was designing this path in Inkscape, which is the original, this is clone. If you look at the positions here of the control points, they are created in pairs. Almost. And they are just shifted up or down. Or maybe we'll play with animation later. But you could totally animate those flags, they could really wave. We should definitely put some color on them. Actually, they are very simple, the colors here. They go from full red to half red. Points. I think 5 points should be enough for us. Going to be null. We don't have many colors. This will be 2 colors repeated a couple of times without the last one. Okay, we just have to extend this a little bit.
I'll make this slightly angled. I think it will be more interesting this way. Almost. I just want to position this gradient nicely. Okay. So we have our flags. The flags here, they have shadow. But I don't want to kill performance. Shadows can easily destroy it. Let's do other things now. Register icon. Yeah. I think we should include this library instruction. Now that we have this, we can use the register presentation array. Find the icon. It is obviously going to be drawn at the wrong position, but we will fix this.
Ride a giant hit to Africa and rape all the natives, says.
This is so.
I think we can, yeah, just translate it to the proper position here. Let me open YouTube settings. to all chat, and now I can ban. Cool. Fixed. So this translation here. We would like to move this so that this point here should be in the, like in here. I don't think I have any good methods to access the size of this image. Yeah. I will move to the, not top of the inner rect, but base rect top. Minus some fraction of the image size. Yeah, and we have icon on top of the checkerboard now. You can really see the compression here. Okay, maybe I will move this a little bit more. 0.1.5, let's say. So on those register icons, I should probably regenerate them using some fixed points. So, not points, like guidelines. So that it's more clear when a register starts or ends. Oh, actually, it's cut off here. It's because I should probably increase it by 11 millimeters. Yeah, it was extending beyond the texture size. So the interesting thing is that now, when I move this register, because it's a widget and it's cached, it should be stored as a bitmap. So I should be able to move this, and this is not being redrawn. We are reusing the texture and just offsetting it a little bit. Okay, so this is our register with flags, with icon. Now we want to show the byte values on the right and the bit positions below each bit here. I actually wonder about which font we should use for that. So using a different font for hexadecimal values, that would actually make sense. Okay, let's start with bit positions, because this is easier. We will do bit positions using standard fonts. It's going to be really tiny. I wanted to do, okay, I remember. It's because I want to take cell height divided by 2, and this is going to be our font height, so that it will nicely fit inside the register, sorry, inside the cell. Yep.
cool. Yeah, and we need to translate this. Nice. It is pretty heavy, but it makes it also kind of readable. Okay, one thing which is a problem in this font is that it likes to go below the baseline. Many letters actually do. Some of them are perfectly aligned. Some of them like to have this overhang. I'm not sure what to do about it. It looks really nice. It looks better in this design. Maybe it's a little bit too heavy. I'll see what variants do we have. I could switch to regular. I think regular might be a little bit better, but the overhang is still a problem. So let's try to make it smaller and shift it up a little bit. I don't like that it's unreadable, but maybe it has to be. Okay, the way I see this, I think we are almost there. It's almost touching. There is probably no point making it any larger. I could align it to the right. That would put more distance between the flag and text, but it's probably not necessary. Those were bit positions. Now bit values. So specifically to the right of this widget, we should display what those flag combinations to what hexadecimal numbers do they correspond to. I'm not sure if this is a good idea because I was actually playing Human Resource Machine, and even working with decimals, purely with decimals, Human Resources Machine was still complex. I will do something else right now, something which is also causing some issues. The assembler arg, this argument, right? It has a style. Let's create invisible style. Okay, here we have tick function. What happens when we animate a connection? We do not animate invisible connections, so okay, and inside the draw function we do the same. If it's invisible, then we just finish. So that should solve the problem with red lines going to the assembler. There we go, much cleaner.
Cool. It seems we can render this properly. Oh, not always. I see an issue here now. I wonder what changed. What's causing the lag right now? I would say we did quite a lot from the widget. We'll do the hexadecimal numbers as well. I'm hesitating whether to add them, but I think I will. Quickly see what fonts do we have. Noto sans, yeah, I guess it's fine. We can use Noto sans for hexadecimal numbers. I think we should be able to find a better font. So let's leave it to do here. So this will need a font and shapes, colors, etc. I actually don't know what we will need. So we need something like a visual style, something that would, when you look at it, would immediately tell you, hey, it's a hexadecimal number. Right now, I will just go for Noto sans. Or maybe Grenze. Yeah, maybe Grenze. It is a little bit laggy now because I am compiling in the background. I should probably not write code right now. So I will use this time to do a short break. Be right back.
Fascinating. It looks like we've been compiling Skia and LLVM in parallel. I'm surprised it worked. Okay, it appears that it will take a while, but at least the editor became more responsive now that one of the compilations finished. So really what I want to do here is not inner rect, this will be base rect, right? And bottom. Okay, that should not be light paint, that should be dark paint. And byte value should be it's taking a while. So I think, I haven't seen the results, but I think we've just added byte values. I could maybe push them like by 1 millimeter to the right to create some matching, because they shouldn't touch. I guess we're just going to stare at this while it compiles. Let's create some to-dos. Okay, so what do we want? We want to have effects on the border, so this darker edge, lighter edge. We want to have lights on the border. We maybe could add those lights right away. So there could be one in the corner. Positioning those lights is not going to be super easy. So what's the... Okay, let's say we will draw a rounded rectangle that goes through the center of the border. We can compute its width, its circumference, its length. So this will be the so the corners we can calculate using circle, circumference, and the lengths of the rectangle together. So that could give us the length of this whole thing. Next, once we have the length, we could say that, hey, we want to put lights on it, and the number of lights should be divisible by 4. Because one light will be in each corner, and then as we follow this line, there will be one light, you know, after every fixed distance, right? Because we want to maintain fixed distances between lights. So this way we should be able to programmatically draw the lights. It's not that late. Maybe we can try today to do it today. So there is the idea about connecting this widget with the actual running assembler, which we have to do. It's probably the most important thing right now. It should actually display whatever is happening inside the traced process. Thread, process, it's something in the middle, because the way we spawn it is weird. All of those things here, because here we have to-dos for the instruction widget, assembler widget. So many missing things. This rename, yeah, I think we will just keep calling this assembler. Okay, I think we will have to work on the backend. backend, meaning that we really need to implement this multi-threaded kind of tracing system. So we need a separate tracer thread. Why? Because Automat uses multiple threads, and each of those multiple threads may want to interact with the assembly system, and it's just not possible from arbitrary threads. Linux forces us to have a fixed tracer thread, and this is the only thread which can actually do ptrace operations on the assembly thread. So normally I would not introduce a separate thread. We would just use whatever thread we are on. But it's not possible. But that's nice. It's going to be a nice library, and we can probably spend Friday working on this. And maybe we will be able to hook it up to the widget. How is the compilation? 200 more files. Oh yeah, this, I thought about this, and I have an idea. I think when we create long-running when an object runs for a long time, it needs to return a long-running instance. So this is something that can be cancelled. Automat uses this so that when things get slow, or like not things, when things get slow, so that user can cancel long-running operations. What we will do is we will turn assembler into long-running object, and when it starts executing, it will attach itself to all of the instructions. So when it starts, all of the instructions will be marked as, hey, they are running. And it will be possible to call this. It's so... I don't like the latency. Oh well. Okay, those values look good. They should be hexadecimal though. Or actually not that good. They are slightly too large. I would like to make them smaller. Oh, it should be hexadecimal, so X here. I was probably too late. Apparently not.
prefer uppercase text here. Can I just use capital X for that? I feel the visual weight of letters and numbers is different here. Numbers look good together, but when you combine them with capital letters, not anymore. So let's try the Noto. Get Noto Sans. Should be a fixed width font. Let's check Google Fonts. Filters. We want monospaced. Ideally something that's kind of technical. Silk screen looks nice. Yeah, let's grab it. Let's put this in the README. Cool. So this is the regular, and this is probably the bold variant. And they are both nice. And it's tiny, 17 kilobytes. Nice.
the name. Oops. This is how it's named. Let's see how this looks. I think when I add a new asset, this probably didn't had the modification time. And like, yeah, it says 2002. So what's the issue? First of all, yes, this asset exists. What could be the issue here? Oh yeah, it shouldn't be static, absolutely. Okay, the problem is it's not fixed with. It was supposed to be fixed with. Come on. Okay, apparently I cannot select multiple filters. Let's see monospaced fonts. There is these pixely fonts. Is this monospaced? By the way, this pixel font, I'm keeping it. It's definitely going to be useful somewhere. It's a very nice, simple, basic font. Something like this is necessary. It's actually not a bad font. It's not very... Or maybe it is technical? I will keep this around.
There are no cute or fancy monospace fonts. Weird. Calm. We don't want calm. Don't want business. I think this shape, it feels like ink because it removes sharp edges. It's not the feeling I'm going for. Okay, reset all filters. We want monospaced. There are not a lot of them. Actually, I think Nerd Fonts Mono, they have more interesting variants. There is this hexadecimal, sorry, the hexadecimal, this pixel-based font. This looks cool. Oh, it's heavy. It's actually heavy. Maybe there is a standard version without the nerd font additions. Looks cool. Suddenly it's tiny. Suddenly it's 16 kilobytes. Fonts can be really small. It's actually hard to find the reference page. Oh, wigfinger.com. Okay, maybe this website will be back.
By the way, this heavy data, okay, there is just one variant here. There is a license. Nice. I mean, I love this kind of stuff. When somebody just makes font and just puts it out there for free. It's like, it makes just everything so easy. Like, there are people who want like hundreds of thousands like for each design font, like design studios, right? It's crazy that we can do this so easily now. It's great. It's very space-like, fits very nicely, and it's not fixed width. Come on, that was looking so nice. You know what? I will just center this stuff. Or not. Doesn't matter. It doesn't have to be centered. It's fine. I like the font. The font looks very nice here. It screams, hey, this is a space font. Can make it smaller. Okay, I think there is something strange happening here. Why the spacing seems wrong now? And again, there are some weird things happening with character spacing. So I think this is actually fixed width. It's just our font layout doesn't work great.
Those also might be nice. Proggy clean maybe. Okay, this would be weird if this fixed anything, but maybe I'm releasing some memory that I shouldn't release because I'm passing this as string view. No, it didn't change anything. Okay, now suddenly it looks like everything is aligned. Yeah. It's 3.3.5 millimeters. Maybe let's try specify this size manually. Okay. Looks nice. Two and a half millimeters. And we have issues. Now this kind of snapped together. I have no idea, maybe there is an issue with the font. Unlikely, because it works at different scales. When it's 3 millimeters tall, it works perfectly. I will just keep it like that. There are some weird things happening there. I think we would have to use debugger to enter this text shaping code. Honestly, it's not bad. It's passable, I think, this register values. And they are in hexadecimal, so we can see 1, 2, 3, 4, 5, 6, and so on. This is exactly the value that we are setting in the constructor here. Okay. I think we have a lot of things, we just have to combine everything together. I think, we also had this problem that in release build, this is release build, and this is, we had issues with the flowers, but apparently they went away. Nice. Our sloppy textures. This is why I prefer vector images. When we do stuff with vectors, you can really not see any issues. Okay, maybe there is an issue here. It's fixable though. I know what's the issue here. It's that when I move this thing, the tick function is called on the location, which animates the position of the location, and the location it notifies the widget that, hey, your position on screen has changed. And the widget has, okay, so now I also want to animate, I want to redraw my stars. But we are already packing a frame, so the fact that you are notifying us at this point, it doesn't matter, right? So this is why the star animation, it works smoothly when I zoom in and out, because then we are actually forcing the smooth animation. And
when I stop and I start moving this around, it becomes an issue. And also it is an issue when I move the screen like that. Well, we'll fix this. The solution is going to be I don't know if it's going to be easy, probably not, because our rendering code is total mess, but it will fix some issues. It will simplify a lot. So the rendering performance is not an issue. The issue is calling the tick at the right point in time. Okay, we're also showing just one register. And really we should track So if we are using the CX register or the DX register, when we set a value to this register for the first time, it should be shown here, and then it should go away when it's not needed. We need lights and we need hand. But to draw the instruction pointer, I think we will have to finish our tiny debugging library, like semi-debugging library. I actually don't know how we will do the arm, because this object has a texture with a fairly limited size. I don't know why shadows sometimes work, sometimes don't. I just don't get it. Now they work. I zoom in and they stop. It's weird. There are just some zoom levels where they kind of work. Okay, then we could animate the flags. For fun, there is like absolutely no reason to do it, but they could wave, that would be fun. And other things, this image, we should regenerate it. It shouldn't be, this doesn't look like axolotl. It It should actually resemble the lizard. Sorry, the salamander. So I've also had some plans about appearance of a register. So when a new register appears, I wanted this to kind of fly from this space, so all of them would get smaller and the next one would appear. So we need some kind of layout for those registers. Then there is also the hover responses. So when I move my mouse over this register, I should probably just highlight stuff. It doesn't mean that clicking this will do anything, but highlighting stuff makes it easier to understand what you're looking at. So for instance, when you hover over a position, a cell on this table, we could highlight the digit that would be changed if you click here. Okay, I guess that's it for today. On Friday we push and we'll do this. We'll see how it goes. Okay. Thanks everybody and see ya next time. Bye.